Welcome to Bill's Garage. Ton structure, we had to talk like, basic stuff. I don't know why I'm making this, because I'm probably going to do it in the classroom, but in case somebody misses it, I got you covered. Alright, so we've all seen atoms, like, when we were in grade school in science class. You got protons in the middle, they're positively charged. You got electrons that are negatively charged. There's the same amount. And then we got neutrons that also live in the center. We'll talk about it. All right, so we have free electrons. And usually there's an electron balance in them, but we can excite the atom by putting energy into it. Okay, and that causes it to, the outer orbit of the electrons to grow a little bit, and that makes it unstable. It doesn't like that. So as soon as it gets a chance, it pops one off, and then it shrinks a little bit. So it gets bigger, accepts energy, gets smaller, releases energy. Now, that electron that pops out moves to another atom, and that in turn, makes it bigger, makes it unstable. Get where I'm going with this? It's kind of a chain reaction. We'll talk more about this. So we have the flow of electrons. Now, what do we ask electricity to do for us? We ask it to do a few things. Light, heat, motion, information. Those are the basic four that we ask it to do, especially in an automotive environment. Now, there's two competing theories about which way electricity flows. One is positive to negative, and the other one's negative to positive. A lot of big brain guys, smart dudes, try to figure this out, and honestly, we don't have a good answer. We okay with that? We're going to pretend that we know, and we're going to use the electron theory, which means it flows from negative to positive. We okay with this? Now, this is just a simple circuit. Here's my power source, and then here is my load. That's the work that I ask it to do. Load. And then we have a continuation of the electron flow. Now, some of the electrons are changed in this particular load, this is a light bulb, change into light and heat. Okay, so we've got some radiated energy, infrared, and energy that's radiated up in the form of these electrons that are being used. And then we also have electrons being changed into photons, which changes it into light. So that's how we get a light bulb. Anyways. So how does it get there? Well, it travels through the copper of the wires. And we'll talk more about this a little bit later when we get to wires and stuff. But, it's filled with copper. And, well, for the most part, we can use other things, aluminum. But for the most part, in automotive land, we use copper. It doesn't corrode as bad. Anyways, so this is full of copper. So we push some electrons in at one end, and it travels to the other end because it excites these guys, and then it uses some. And then what we have is we have unstable atoms on this side that are full of holes. So we got electron flow on the negative side, and we got hole flow on the positive side. Remember, we've used some electrons. We've changed them into photons and heat in this particular, instance. We okay with this? All right. Now, in order to get electricity flow, we need a couple of properties. We need a massing of electrons, high voltage at one point in the circuit, a lack of electrons, holes in another part of the circuit, and a complete circuit. Now, we hope that it does something useful. Remember, light, heat, motion, information. We'll talk more about these later. All right. Voltage and current. Voltage is the driving force. It's the pressure behind it. Okay? Current flow is the amount of electrons flowing past a certain point. And that number is 6.28 times 10 to the 18th. If you get scientific notation, that means there's 18 zeros on the back of the 6.28. We okay? I'm going to talk about this when we get into class. More on this later. And then we have ohms. Now, ohms is a property of the load. Hopefully, that's the only place where we want some resistance in the circuit. This resistance, this ohms, think of it as, you're driving to school this morning, or, driving to work and you run into traffic. Well, that's a resistance to flow. I'm sure we've all had that happen. More on this later. Now, forgot to say this. This is a product of the load. Okay, so resistance is built into the load. There is some peripheral resistance in other parts of the circuit, which we'll talk about this in great depth. Then we have the conductors, and that's the wires themselves. Now, these have lots of free electrons. They're easy to excite. We can easily, move electricity through them. What can we move electricity through? Well, copper works, aluminum, virtually anything. Given a high enough pressure or voltage behind it, we can move through, a conductor. Now, insulators. Now, this has little free electrons, so it's hard to excite. So, some properties of insulators, or some types of insulators, is, like rubber or ceramic or, porcelain, mica, Teflon, glass. Are those good insulators? Well, it depends. And again, we're dealing with higher voltage pressures. Okay? Look at a lightning strike. Really high voltage, but it can jump this big air gap. Spark plugs. We use 30 to 40,000 volts to jump the little tiny gap in a spark plug to light the cylinder off. We good with this? Now, the other thing that we use electricity for is information. I mean, if you pull out your phone right now, you look at it and you have bars. Well, that means you're getting some information. The phone can see the cell tower. So now that's not a lot of voltage. It's very, very low voltage, but the frequency is very high. And more on this in class. So, insulators and conductors, depending on the environment that it's in, anything can be a conductor, and anything can be an insulator, given the right set of circumstances. Got it? Functions of electricity: light, heat, motion. What's the last one? There you go. All right. We also have magnetism thrown in there. Now, I'm sure you guys know about magnets, right? You have, magnets stuck to your refrigerator. The pizza place. Your insurance company, maybe a little buck or something stuck to your refrigerator. Well, those use magnets. Now, the interesting thing about magnets is we can use electricity to manufacture a magnet, an electromagnet. I'll show you that. We'll talk about it in class. And then we can also use a magnet to generate electricity. So magnetism and electricity are tied together, and we will talk a lot about that too. All right? Any questions? Thanks.